All right, sorry I got cut off there, so I'm going to finish this example. All right, anyways, we square rooted both sides, so I get plus or minus root 3 equals tangent of x. All right, now that we've got x by itself, or tangent of x by itself, I have to find out which quadrants of the 4 quadrants where tangent is both positive, or where tangent is positive or negative. What that means is basically we're talking about every quadrant here, because tangent's positive in quadrants 1 and 3, but negative in quadrants 2 or 4. So what this means is I'm actually looking for 4 answers. So remember, our interval is from 0 to 2 pi. What that means, I only want answers from 0 to 2 pi. So I'm only looking for those 4 answers. I know before we left on this extended break, we talked about kind of memorizing a few things, and this is one of the things that I kind of suggested that people memorize. Like, what angle am I referring to here when I talk about tangent of x equals root 3? Remember that you could either be 45 degrees, 30 degrees, or 60 degrees. And if you remember, tangent of 60 degrees always gives me an answer of root 3, whereas tangent of 30 degrees gives me an answer of root 3 over 3. So why that's helpful is now because I know I'm talking about a 60-degree angle, which means that I'm looking for pi over 3. So my answers are pi over 3, because that's the first quadrant angle. In this quadrant, it would be pi minus your angle, so this would be 2 pi over 3. In this quadrant, you would do pi plus your angle, so that would be 4 pi over 3. And in this quadrant, you would go 2 pi minus your angle, so that would be 5 pi over 3. These would be my 4 solutions for this example. All right, next one. I'm back to general solution here. This time I'm asking for 2 cosine cubed x minus cosine of x. I just want to also show you that if it gets confusing about to think about what you need to do when you're solving a cosine or a sine function, you can always kind of ignore the cosine and sine. Let me show you what that means. So like instead of saying 2 cosine cubed of x, I could just call this 2x cubed minus, and then instead of calling this cosine of x, I could just call this x. If I gave you this function right here and I asked you to solve it, would you know what to do? Hopefully you would tell me you would factor out an x, and then you would set each of your factors equal to 0 and solve. And the reason why this is helpful is because we're going to do that exact same thing over here with this cosine function. So the first thing I'm going to do is I'm going to factor out a cosine of x. And that's what I get. Next, these are both my factors. I'm going to set each factor equal to 0. So there's that one and this one. And now I'm just going to solve. This one's kind of already solved for x, so I'm going to look for when is cosine going to be 0. Since cosine represents x, we know that cosine is 0 at 2 spots, and that's at 90 degrees, so that's pi over 2, and 3 pi over 2 at 270 degrees. And then back to this one, I'm going to go ahead and solve this equation. I'm going to add 1, I'm going to divide by 2, and I'm going to square root. Don't forget your plus or minus. The square root of 1/2, remember, is just going to end up being root 2 over 2. All right, so now I'm going to solve this one. I want to know when cosine or x values are both positive and negative. That's in all 4 quadrants. What angle am I talking about if I have a side length of root 2 over 2? Remember, it has to be pi over 4. So I'm looking for a pi over 4 or a 45-degree angle in every quadrant. So my answers are going to be pi over 4. This would be 3 pi over 4. This would be 5 pi over 4 for quadrant 3. And then in this one, it would be 7 pi over 4. Now, because we asked for general solutions, you could go ahead and just add 2 pi n to every one of these answers. There's another way to think about this, though, and I just want to show you in case you care. Another way of writing this, instead of writing it like as, 2 separate answers with 2 pi over n, I could write it like this. Do you see how this answer, or I could write it like this, or this answer is the exact same thing? By saying I'm going to take pi over 2 and add just every multiple of pi, that actually gives me pi over 2, 3 pi over 2, and then back around the unit circle again. So technically, writing it like this, or writing it just with one equation like that, basically they're the exact same thing. So I just want to show you that you have some alternatives of how you can write your answers. Same thing goes over here. I could write this as x equals pi over 4 plus pi n, and that gives me these two right here. And then I could write x equals 3 pi over 4 plus pi n, and that gives me every multiple of those answers. So it just streamlines your answers a little bit, so if in case you're curious or see that somewhere. All right, another one. This one's a little bit more complicated. On this one, what I'm asking you to do, I'm asking you to solve, but I'm asking you to only solve between pi and 2 pi, which just basically means I'm only looking for answers from 180 degrees to 360 degrees. If this confuses you, you don't know what to do, remember you always have the option of kind of thinking about it as without the cosines. So I could think of it as 4x squared plus 4x equals -1. If I gave you that equation, would you know that you would have to add 1 to both sides and then factor your equation? If you remembered that, then we're going to do this problem here the exact same way. So I'm going to go ahead and add 1 to both sides, and then I'm going to factor this into 2 cosine of x, plus 1, and 2 cosine of x plus 1. Because these are the same exact factors, I only need to really solve one of them, because they're going to give me the same answer. And so as I solve this, I'm just going to subtract 1, I'm going to divide by 2, and then I'm going to say, okay, when is cosine going to equal -1/2? Cosine would be negative in those two quadrants. And we did this one earlier where this was -1/2. Remember, this was a 60-degree angle. So my answers are a 60-degree angle in the second quadrant would be pi minus pi over 3. So in other words, 2 pi over 3. And then my other answer would be 4 pi over 3. But remember what we talked about? Remember that this interval right here between pi and 2 pi means I only want answers between pi and 2 pi, which then means that this answer technically doesn't meet our criteria. So this would be the only solution to that problem. Okay, this one was a little bit more of a challenge. And so what I wanted to show you, this is definitely a challenge problem, and I thought this was kind of nice. The next two are. So I have sine of 2x plus 1. You would start by kind of doing this the same way. The issue we run into here is that we don't know how to solve for like sine of 2x. So what I'm going to suggest is so I'm going to say let theta equal 2x. And what that does is now I can rewrite my equation. Instead of saying sine of 2x, I can just say sine of theta. And what that allows me to do is I can solve this because we know how to do this one. So I'm just going to go ahead and solve this equation now. And so this is basically asking when is sine going to be -1. And remember, that's your y value, so that's down here at 3 pi over 2. So that means theta is going to equal 3 pi over 2. Okay, so because we let theta equal 2x, I'm now going to go back and substitute 3 pi over 2 back in for theta. So 3 pi over 2 equals 2x. Remember, our goal is to solve for x. So I'm going to multiply both sides by 1/2. I get 3 pi over 4 equals x. Remember, look at your intervals. Remember, I want answers from pi over 2 to 3 pi over 2, which 3 pi over 4 does fall within that range, so we're good to go. All right, last one. This one's another challenge one. You won't see any problems on your homework like about this, but I figured since you're honors, you may want the challenge. All right, so on this one, it's cosecant, which is one of our reciprocal functions. So we're going to start off by doing this the exact same way. I'm going to go ahead and add 2 to both sides. And I'm also going to go ahead and square root both sides. Don't forget your plus and minus. Here's the catch. If you're dealing with a reciprocal function, you must now take the reciprocal of it. So the reciprocal of cosecant is sine. And so now what I'm going to do is I'm going to take the reciprocal of root 2 over 1, which is 1 over root 2, which is root 2 over 2. So now I'm going to go ahead and solve this equation. When is sine positive or negative? That means all 4 quadrants. And we're talking about a 45-degree angle here if we're talking about root 2 over 2. So basically I'm going to name all of my answers 45-degree angle in every quadrant. So pi over 4, this would be 3 pi over 4, this would be 5 pi over 4, and this would be 7 pi over 4. And that's how you solve a reciprocal function.